Good morning, students. So let's look at this question now. Dinitrogen and dihydrogen react with each other to produce ammonia according to the following equation. Now, what do we need to do? We need to find the mass of ammonia that is going to be produced if 2 into 10 power 3 grams of dinitrogen reacts with 1 into 10 power 3 grams of dihydrogen. Then the other questions which are there are, will any of the two reactants remain unreacted? If so, which one? And what would be the mass that will remain unreacted? Right? Okay, great. So now let's go step by step. You see here, we can clearly see from the equation, right? We have N2 plus 3H2 giving 2NH3. What does that imply? 1 mole of nitrogen one mole of dinitrogen combines with 3 moles of 1 mole of dinitrogen combined with 3 moles of dihydrogen to give 2 moles of ammonia, right? So how many grams of dinitrogen? Say nitrogen atomic mass is 14. So 1 mole refers to molecular mass expressed in grams. So that will be 28 grams, right? So 28 grams of dinitrogen combines with 1 mole of hydrogen is hydrogen gas is 2 grams, right? 3 moles means 6 grams. So 28 grams of dinitrogen combines with 6 grams of dihydrogen to give ammonia. You see the molecular mass, it is 17, right? So 1 mole is 17 grams, 2 moles will be 34 grams. Is that clear? Right. Now, if you see, what is the ratio in which it is getting consumed? If you see, 28 gram of dinitrogen combines with 6 grams of hydrogen, correct? Giving 34 grams of ammonia, correct? So now, if I'm going to divide throughout by 28, right? Suppose if I divide throughout by 28, so I shall see that 1 by 28 of a mole of dinitrogen combines with 3 by 28 of a mole of hydrogen to give 2 by 28 the mole of ammonia, right? So what does that give us? 28 gram divided by 28, that gives you 1 gram. So 1 gram of dinitrogen would combine with 6 upon 28 grams of dihydrogen to give 34 upon 28 grams of ammonia. Clear? So now we want 2000 grams of dinitrogen to react. So what do? I just multiply the entire equation by 2000. So what would I get? So 2000 gram of dinitrogen would combine with this multiplied by 2000. So 2000 into 6 divided by 28 to give you 2000 multiplied by 34 divided by 28 gram of ammonia, right? So now let's see what these numbers are. As you can see, 2000 gram of nitrogen combines with 428.57 gram of hydrogen to give 2428.57 grams of ammonia. So answering the first question, right? Calculate the mass of ammonia that's going to be produced, right? So now you can clearly see that the nitrogen is completely exhausted, right? right? But you have hydrogen 1000 gram, out of which only 428.57 is utilized, isn't it? So here you can clearly see that the limiting reagent is here nitrogen, dinitrogen, and the one which is taken in excess reagent is here dihydrogen, right? Out of 1000 gram of dihydrogen, only 428.57 is utilized. Remaining 1000 minus 428.57 gram of hydrogen would remain unreacted, right? So answering the first question. So how much of ammonia is produced? So that's going to be 2428.57 gram. Is that clear to you? Now, next question. Will any of the two reactants remain unreacted, right? So we can clearly see that we are taking 2000 grams of dinitrogen and it is completely being consumed in the reaction. Whereas we have taken 1000 gram of dihydrogen, out of which only 428.57 is being utilized. Therefore, there is some mass of hydrogen which is remaining unreacted. Yes. Therefore, will any of the two reactants remain unreacted? Yes, is the answer. Which one? It is the dihydrogen. Last, what would be its mass, right? So the mass of dihydrogen which will remain unreacted, mass of dihydrogen that remains unreacted is equal to, totally I have taken 1000 gram, out of which 428.57 grams is reacted. So how much remains unreacted is 571.43 gram. Hope it is clear